All right. By the way, we're still getting ready. But that's my backup just in case the live stream isn't actually working. I'm not going to double check it. But because that's how confident I am, right? Yeah, yeah. Okay, so one, I don't ever prepare a slide, but I should say it is that Orlando AWS User Group is, you guys didn't know, is officially under ODevs now. So logistics wise is mostly because I'm the vice president of ODevs, so it was a little bit hard to do both separately. So if for those of you guys that don't know, Orlando Devs is a nonprofit that helps bring together different disciplines of technology, and kind of the goal is to just showcase tech in Orlando, which totally works with Orlando AWS User Group, right? Because it's about tech in Orlando. And I really, the long spiel of this is because Anisha is not just, our, an AWS guru in Orlando, but also, I mean, it's still October, so she is also a woman in tech, and we're gonna celebrate that, right? So I'm gonna just give it over to you to introduce to yourself, but thank you everybody for coming, and thank you everybody who's here virtual.
So yeah, hello everyone, I'm Anisha. So I have been working as a data engineer for past 3 years now. So I'm working with pipelines and building backend systems. So lately, I have been learning modern architecture, right, with involving like real-time systems and event discovery. So that is what I've been learning lately. So today, what I'm going to talk about is like, as the topic says, synchronous to event-driven architecting for real-time system. So before I dive in, let me ask you this one simple question. Um, you must have ordered online food, right? And while ordering it online, you must have faced this where you refresh your screen again and again to check if the order has been placed or if um, the delivery guy has taken in your order or not. You keep on refreshing the screen, and those instant updates that you get, that is all about the real-time system architecture in the background, right? So that is what we're going to talk about. Like, today we'll walk. Okay, this is the system, right? Today we'll be walking through the monolithic architecture to microservices, and in the end, we'll go on to event-driven architecture. Yeah. So before I like dive into the architecture diagrams and patterns, uh, meet the cast. This is an example that I'm going to use to represent all the three different architectures that are there. So here, Alex is a DevOps engineer who is responsible for creating the automation, CI/CD deployments, and ensuring that the release is smooth. We have a dev team which consists of across more than like 20 developers, and they are spread across 3 time zones. And Sam is their engineering manager who keeps track of all the projects and timelines and the tasks should get completed. So that is Sam. And GitHub is the place where all the repositories live. And Slack is where the actual communication happens between the teams. So Sam has lately been missing important deployments. So that's a problem statement. Like she asks Alex, like, can we get notified in Slack when the code is pushed to production branches? So basically, she needs a notification system as soon as something is pushed to the prod repository or branch. So this is what the cast is about. We'll be taking this problem statement and we'll see how monolithic microservices and event-driven architecture thrives for this particular problem statement. Yeah. So here, Alex, as I said, she's asking for a Slack notification system where she gets notified as soon as something is deployed onto the prod branch. So Alex agrees to it, and he comes up with a 30-minute solution, which is nothing but in a monolithic environment. So what does monolithic mean here? Um, all the code, monolithic systems are developed in a way wherein everything is incorporated in one single script and uh, yeah, in one single script. So that is what he does basically. So here he sets up a GitHub webhook, which is nothing but a system for GitHub wherein it allows external applications to get notified as soon as an event from GitHub happens, right? So he set up a GitHub webhook. The GitHub webhook, it sends a response. It sends a response in HTTP post, and the same is getting routed through API gateway. And he has written a code in Lambda which allows the notifications to be sent to Thrive. It has a code which is responsible for notifying in the Slack that, okay, someone from the development team, suppose ABC, has pushed their code into the prod deployment production. So this is a simple architecture. This is a simple code that he pulled off so that the problem to get notified into the Slack is resolved. But a few days later, Sam comes up again with other requirements wherein she wants some analysis wherein she could track the deployment frequencies for the team. So Alex adds in some more code to it. CI/CD applications are also deployed through the same Lambda code. So more code is getting added. So this is how the architecture looks as of now. Like this one Lambda, it is handling the notifications that are being sent to Slack. It is enabling the analytics by storing the data into one of the databases, and it logs audit. It logs into audit logs for compliance purposes. So this one Lambda is handling 3 different tasks here and more as the requirements keep on increasing. So this is what Alex goes through whenever the code keeps on getting added. Like if he has to deploy, suppose he added an analytic code and he is going for a deployment stage, right? He has to ensure that the notification is not broken down. He has to ensure the audit logs are in place and the code does not get disrupted. So the deployment is at risk, right? The simple code, which was just meant for sending notifications to Slack, has now grown into a 259 code. So also testing, like if he has to make some changes to that code, right? What happens is he has to test all the other categories as well to ensure the code is up to date and it does not break. I mean, adding one code does not break something else. So that is a testing overhead. Also scaling limitations. Because there are so many different tasks happening in one Lambda function, it is tightly coupled, right? So scaling just one notification service won't be possible. You have to scale the entire Lambda. So he understood that as the requirements grow, monolith is giving him problems. And finally, it breaks down, wherein one day the Slack API, it slows down, okay, which then makes the Lambda wait, and then the DB connections get piled up. Also, audit API also starts failing, which in the end, Lambda times out because Lambda has like a 15-minute 15-minute barrier, wherein after 15 minutes, the operations would stop working. So the entire system crashes down. So a single slow API here, it brought down the entire system, right? Such failures are called as cascading failures. So Alex understood like, as and when the requirements increased, right, it became difficult for him to maintain the code, okay, deploy it, and even testing, as we discussed earlier. So these are the limitations which uh, he felt while, uh, designing it, like as the requirements increase, like coupling it was tightly coupled. He couldn't scale a service individually. There was risks, right? One change in the code could risk other tasks to not work properly. And also bottleneck, also bottleneck wherein um, all the teams had to touch the same code base. Okay, so it became difficult for him to manage. But when is this monolithic architecture good to be used? It is good to be used as starters when the team is small and there are less dependencies, early stage startups or MVPs, and applications with lesser external dependencies. So that is when you could use the monolithic architecture. So now he had to come up with a better solution to avoid all the issues showcased by monolithic architecture. So he decided to break things down. So he decided to redesign the architecture with microservices. So basically, what if he splits those responsibilities and each of those services handle their own responsibilities on their own? So that is what he did. We are splitting this into microservices. Each concern has its own service, and that will be is easier to scale and deploy, right? Um, so this was all the transition, like it transitioned from monolithic to independent scalable services, wherein microservices, if I explain, it is nothing but like independent services which communicate with each other, and it works to build a bigger task workflow. So these services, they communicate with each other via network communications. If you see here, the initial part of the diagram stays the same, wherein the GitHub webhook response is routed to the Lambda, and the Lambda then decides and it distributes the responsibilities to each of these services. Like if you see, there's like Slack service Lambda, analytics service Lambda, and audit service Lambda. So each of these will do their own specific job responsibility and return back a response to the webhook receiver Lambda. So now what this solved was, each of these services had their own DBs. Each of these own services were independently scalable, right? So this helped him scale the requirements. If he had to add anything else, so he could have like separated it and attached to this webhook receiver Lambda, wherein the responsibilities would be distributed, right? So why we move to microservices? As I said, independent scaling. Now the Slack service could be scaled independently without changing any code for analytic or audits, right? And independent deployment. The earlier, like changing one thing, we had to check all the other tasks as well if it is working correctly or not. But here, we just change something on the analytic service, and it should, uh, it should work well. You can just test it and deploy the same. And the third thing is the tech stack freedom per team. Right, earlier the entire code in Lambda was in Python, right? But here, the different services have their own Lambda functions, which allows them to use different languages. Like the Slack can use Python to send the notifications. The analytics services can use Go language to, increase their production time, and the audit team can use Java to maintain with their legacy code, right? So this allows them to use Stack as per their usage, as per their requirements. But when he thought that, okay, this was going to solve all the problems that Monolith did, but uh, he came up with this issue where the developers started complaining, oh, I am not able to see the notification on Slack when I push my code to production. So why was this so? He went back and checked the CloudWatch logs, and that is when he saw like the analytic services were lagging, right? And due to which the Slack service was also not able to send responses. But this was not tightly coupled. This was not supposed to be tightly coupled. And that is when he discovered that these, though he separated all these services, okay, but he could not separate the time. They were dependent on each other. They were synchronous. That is when he thought that, you know, in when he tried to separate services, okay, he instead built a distributed monolith, right? Where earlier, monolith was also tightly coupled, but here again, the services are waiting for each other. So this is also tightly coupled. So this also, what it did is, suppose analytic service failed. Okay, so slack.response.okay would give me a 200 response. This failed. Audit response also is a success, but since all the three of them are not a success, it would result in a failure, right? So we broke the monolith, but we couldn't break the dependencies here. That is what this slide teaches us. So what we lost was reliability. The cascading failures still continued. The performances were lowered because here it was waiting for each services to send a response time, and it added to all these, and the performance reduced. It reduced their monolith. Like monolith was better performing than this particular architecture. Availability here, if someone had to test this code, right, all the services should be up. If even one of the services would have failed, this entire system would fail. So availability of all the services must be up. We lost it. And simplicity. So basically, earlier monolithic at least was in one lambda function and we could deploy it in a go. But here, since everything was different services, we made it even more complex, right? So we also lost simplicity here. So what to do here? Alex was frustrated, like in search of finding one solution. He made the system even more complex. So one day, while looking at the logs, he was studying and he got to know there's something called as asynchronous. I'll come to that. Meaning, what if all these services don't wait for each other and are asynchronous? Asynchronous meaning the services, as I said, so services won't wait for each other and just like suppose if GitHub sends me a response, okay, the webhook, what it will do is it will read that response, it will save that event and send a response immediately saying, okay, I have received this response and I'll move on to the next services. So this is what he did, transforming the response with event-driven design. Like what if your webhook receiver didn't wait for Slack? What if it just said, hey GitHub, I got your webhook and published an event. The services consume the event and whenever they are ready. So this is like the architecture wherein um, the GitHub sends a response to the Lambda. So that now the Lambda, what it does is it routes this to SNS. SNS is nothing but simple notification service. It will store that message as an event, and once it is stored, the webhook Lambda would send the response to GitHub. Okay, I got your response. It was successful. And in the meantime, the SNS will push all the messages to the SQSs which has been subscribed to it. So SQS is nothing but a queue, okay, which will hold on to your message until it gets delivered. So here, this particular SNS has three subscribers, that is Slack queue, analytics queue, and audit queue, right? So all these three queues will store these messages, and as and when the services like the Lambda, Slack Lambda, Analytics Lambda, Audit Lambda are ready, the messages will be processed. So in this way, the services are actually independent. Like the Slack service can work independently, analytics works independently, and audit lambda also works independently. So this event-driven architecture works in a way wherein it publishes and subscribes to each other, right? So yeah, uh, that is how the independence and scalable services are achieved using the event-driven architecture. So,
Question,
yep.
quick question. If you go back, no, if you
Yeah.
go back to the diagram that you were just showing, yes. I don't know much about AWS topologies, but it seems to me that the webhook receiver lambda could connect directly to each of the SQS queues instead of going through the SNS component. I mean, why do we need the SNS component?
I think
So the sorry. So I mean I can help you or you want if you want to answer.
go
Okay.
ahead.
So for SNS, it's going to send topics that the SQS queue is subscribing to. So it actually has like a failure path, so it can actually, in itself, it actually handles events that fail. And that's also what the dead letter queue for the SQS, which is gonna be my question to you, so I'll save that. So it's kind of a fail proof at that point, so that's these topics that are specifically being subscribed to, whereas with the webhook receiver, like if you just send directly to the SQS, you can do that. That is a simplified fan out solution. But the reliability actually becomes less because now you're just there's like the reliability comes less because of the fact that now the Lambda function for the webhook has to be aware of everywhere it is sending to. So, or actually complexity as well. So if you wanted to make a new thing, like I want to charge people. If you had the Lambda function, now you have to change that Lambda code to now send to, I want to charge people for this. Whereas now you just add a new topic to the SNS and it says, I'm listening in. So you just hook the Lambda function without having to change any other code. So it's more plug and play.
Right.
So there's reliability, plug and play, so complexity, reliability, decoupling. The biggest thing about event-driven architecture is being decoupled. Sorry. Now my question though
Yes.
is a leading question. Why do we have the SQS queues? Like what would happen maybe if the Slack Lambda failed or something, but
Yeah, it has an inbuilt dead letter queue wherein you can check your failed audit log. Also, SQS, right? It is built in a way wherein if there's any failure, it will retry again on its own. So that is the reason SQS helps us here. Like it has its own retry and it has its own DLQ. So each of these services are like fault tolerant, right? So yeah. So even, I mean, in this architecture, it has actually previous in the previous one, synchronous microservices, though they were independent, but they were not. Here, they're actually independent. Like they can be independently scaled, they can be independently deployed. Also, it is fault tolerant, as I said, right? Wherein they have their own dead letter queues because each SQSs, which is subscribed to each of these services, if anything fails, it will go and sit in that dead letter.
so thank you.
So yeah. So this is just a code like has how you can publish it to the SNS like as a topic, and then once it gets published, it sits in the queue, and when the services are ready to, sometimes it's instantly, but sometimes if any services is down, once it is up, it will go and subscribe to these topics and get the message. So yeah. So basically, what did event-driven architecture solve? It solved a temporal coupling. So before, I mean, in the previous architectures, we discussed, right, like all the services should be online and up. And if one fails, everything fails. But in this case, if suppose Slack Lambda fails, other two are not disrupted, right? They'll go on working independently. So this is what event-driven architecture solved. Cascading failures. If one analytic service is slow, right? It has the ability to bring the entire system down. But here, as if one queue lags, I mean, we can work on it, and as and when it is ready, the message can still be processed. Latency accumulation. So earlier, Slack response time, analytics response time, audit network, all the response time together, it used to take up to 3.8 seconds. But after we have adopted to event-driven architecture, um I mean, just publish it to SNS and return the response to GitHub. It takes like 45 microseconds, milliseconds. So, and then the background jobs run in parallel, right? So it does not wait for any other services like Slack, Analytics, Audit, etc. And then error handling before one failure triggers rollback, like in Synchronous, if someone, if suppose Slack, I mean, or Analytics would have failed, but Slack services would have already sent in the notification, right? You can't unsend a notification that has been sent. How do you roll back in that cases? In this case, the queue retries independently. Each of the SQSs has its own DLQ, that is dead letter queues, which and also the other services do not get affected at all because they are separate. So error handling is done quite well. Testing I mean, before like in monolithics, say, all the services needs to be tested together because it is in one big Lambda code, right? But here, since they are separate, you just publish it to SNS or send test messages to check if everything is working fine. So that should solve that problem. Extensibility, if you want to add a new service, suppose here now with event-driven architecture, you just subscribe to a SNS topic and it will get you the message and it will help you deliver your code. So yeah, before like you had to modify the entire code, test for all the different services. So it used to be like tedious. So but with event-driven architecture, even that is resolved. So this is the comparison table wherein it compares the GitHub response time. Like with monolithic, it took 3.3 seconds. Synchronous microservices, it took 3.8 seconds because it waited for like each and every services. But with event-driven, it took like 45 milliseconds, right? Also availability, not all the systems needs to be available with event driven, so that is the reason it is like availability is increased. With synchronous microservices, 91%, and availability for monolith is 94%. You can't scale monolith independently at all, but with synchronous microservices and event driven, you can scale it independently. Even deploying for synchronous microservices, if the traffic is up and if something is not deployed, you can't deploy it altogether. But in event driven, even that is solved. We have seen that isolated failures does not work for monolith synchronous microservices at all. It works well with EDA and easy to add consumers in event-driven architecture. Yeah. So this is what the comparison is all about. And yeah, thank you. Do you have any questions?
Well, I appreciated one thing that you mentioned was the beginning of this is a very common design flaw that people have is you think you write a Lambda that it's event driven, right? And that wasn't the case. So that was my comment, not a question, but I did appreciate that showing a true flaw that may or may not still be happening at my super nice company, right? So might have hit close to home.
Those slides available, Ingrid?
We can make them available, yeah, she can, well,
Yeah.
I can make it available since you shared it with me, so. Yes.
Now with, when you go to microservices and then to event-driven applications, the complexity also increases, right? Or it's even easier than developing a monolith. What do you recommend? When someone is first starting, right, building an application, they usually go with the monolith because it's, right, it's more.
Easy and fast.
Right.
Yeah.
How much added complexity would you say that each of those next steps take compared to the initial monolith?
So with microservices, everything gets divided, right? So you have to, I mean, what happens is when you're a small team, monolith makes sense. But with microservices, if your company is huge, you have like your own teams to work on different services. But in the end, when everything has to be tested together, it becomes more complex, right? Because everything has to be available. Though they're not tightly coupled, but if they're synchronous microservices, they will be. One service fails, it will bring down everything. So yeah, synchronous microservices are a little bit more complex, and also the response time is, is more than what it is in monolithic.
But the implementation themselves, because it's easier to implement than monolith, right? For a
Yeah,
developer.
It is.
Than a microservice application, which I know that there will be HTTP calls and all over the place, right? And then the event-driven is even harder, right?
Event-driven makes it a little easier. Like you have to just worry about, if you have like different teams on the different services, they just have to worry about their code and not the entire code in total. So
It's harder to develop, right? But it's easier to maintain, I would say.
Yeah.
It's a mindset change.
Yeah.
You gotta change from thinking in what the application is and thinking in events.
Right.
But I think you touched on it really well in the beginning, is that a monolith is a good proof of concept. It's a good thing to start with, and then you can turn your proof of concept into what you can break up into events.
I don't know what I'm data scientist. I don't know what Lambda is, but from what I've seen in this from what I learned in this presentation, maybe it's more like dress for success. If you build in an application, if you build in anything, and you dream big, you want it to grow and be enormous, huge. Maybe it makes sense to start and directly build it in a way that it's scalable. Right? Why would you even spend any time developing something that's not scalable? Right? Like, why am I developing?
I feel like I just got like stabbed. Yes. Slow down the speed up. It's a very good point.
1 week on developing something that will bring you $10, if you can spend 2 months on building something that will bring you $1 million, right? Like, where am I thinking wrong?
About right.
Box that has a timeline.
Exactly.
Yeah, when the person says, I want it yesterday.
Yeah, no, I think the reason why people don't do that, right? If you're gonna read a lot of experiences from all these startups, right? They usually start with monoliths. Why? Because it's simpler, right? Less people to maintain, right? So I think that's the reason why they go with monoliths. If it were as easy to develop, right? I work with event-driven applications, okay, and they are hard. Just tracing an execution, like we have to use what do you call it, a trace ID to trace the executions. We need a lot of monitoring, a bunch of Datadog and all these other very powerful, expensive applications to monitor everything. And still, you wonder sometimes, where did the message go? It's super tough, right? That's what I was saying. A monolith is easy to develop, but of course it doesn't scale the way the other options do, right? course, so it's really good. I mean, AWS has provided an amazing infrastructure for us to make it easier, but it's still a little complicated, right?
Yeah, and I think it touches onto the point of testing and those abilities become a little more isolated, right? So you have your testing of your microservice or whatever ecosystem, maybe not so much a microservice anymore. But yes, it is very tough. And that's why maybe, you know,
The trade-off.
the trade-off is worth it. If you want to scale and be able to handle potentially millions of users on your system, you're not going to do it on a monolith. But you also need to have very, very good bones, which maybe is like part 2 of this. It's like, what is all the CloudWatch logs, all the alarms, all the things that you need to set up to also make sure that you can support it so that, you know, we're not in a Datadog hell but I mean, Datadog likes it because they make more money that way.
Right.
So, but there is ways to do it within AWS if you do it right.
Right.
Is there any questions from our virtual friends? I'm keeping an eye on the chat.
Like you said, it's beneficial if you have the right architect working with the developers, let them know what they're developing for from Jump Street so they can scale out to.
Yes, yes. I mean,
Nobody wants.
probably your advice to anybody would be to, you know, stop and think about what you're doing first.
Yeah, I mean,
Yes,
Right.
yeah, is this, yeah,
Right.
exactly, good points,
Right.
like, is this. Is this the right design? Are we thinking about this where I mean, there's a lot of principles that AWS shoves down our throats. Look, I don't work for AWS, I'm gonna just say how it is, okay? There's a lot of principles, but you know what? They talk about not having tightly coupled systems for a reason.
Like coded in modules, so you can always go back and fix things.
Yeah. Go back, be able to fix something, deploy quickly. You know what the monolith doesn't give you? And I know this might sound like a crazy dream for people, but I mean, it started in the beginning. It's like, whenever we push code to prod, I want to know. It's like, what the monolith doesn't give you is the ability to just when it merges into main, it goes to prod. I don't know how many of your guys' companies actually do that. Yeah, see? But that's because you can trust all your tests. You probably have really good tests. Those have been written well because you have broken down non-crazy monolithic services. Yeah, I mean, I don't know, maybe Facebook has a monolithic service and they do it, so who knows? I don't know what Facebook has, I just like to make fun of them every once in a while. I think what's, again, I'm going back to now the middle solution, right? Almost good enough. But it was very interesting is that it actually was worse than the monolith. And that's a very easy anti-pattern that we can fall into when we try to replace lambdas with more lambdas.
What was the middle, distributed monolith?
The distributed monolith, yeah,
yeah,
which you would think should be better than the first one. But it was actually just,
It
it
makes
was
more
like taking the
complex.
worst of both worlds.
Yes.
It took the complexity of event-driven, right? As you're
right,
trying to say, is event-driven design is complex. It took the complexity of event-driven design and then the unflexibleness of a monolith. But I have seen that, believe it or not, I've seen that design enough times when consulting people. So it is a very easy thing to fall trap, like have a trap go into. Thank you. Is there any more questions? We could open up to networking, talking about different problems. I'll keep everybody online on the Zoom so that if there's anything that we want to talk about in general, you're welcome to do that. Have food and you have to eat the food. So that is like a requirement. I don't want to take home food.
These books.
Oh, these are, I'm sorry for the people that are here virtually, but we do have some free books thanks to our friend here. So yeah. Apparently he'll send you books. Just like,
Yeah, you make friends with him on LinkedIn, he's like, hey, like a book or a box, and see, yeah, the box is okay. All right, you guys, someone at work that might be interested, might be in there, you know, if they're looking at developing a box or any kind of AI, and MCP servers, whatever. Right, extra book. Apparently, this guy's an instructor at Stanford as well, so that's his side hustle.
Is it AWS? It'll be on AWS.
He actually is any kind of development, it applies diagnostic. Everyone that develop. He has his own GitHub page where he has a product called Master.ai, basically AI in the cloud, just not a new concept, but it's his format for
What?
development. I haven't toyed with it, not a developer.
I'm sorry that I jumped in. It's like, I get so excited about, EDA that I'm like, I was like, oh my God, I started talking. Look, you like, I can't control myself. I love it. I'm like, don't leave Joanne unattended with event-driven architecture.
I'm sure he'll appreciate it.
Is there any, anything you guys are working on right now that's, either want to brag about, stumbling new, anything?
I was working on AWS they just recently had an AI hackathon or something, and I was working on that with a friend. It was just to use the AI strands, Bedrock AWS agent, and to, you know, make something. We didn't finish it. It was, you know, busy and stuff like that. So, but I worked on it. It was interesting, but I had a Lambda and I sent the request to the Lambda and it didn't work. And then I put it on, I think I put it on Fargate. I sent the request to Fargate. It didn't work. So when I was looking at your SQS and SNS, I was thinking, yeah, I think I need to do that. That response was time. It was working because I could see the logs in CloudWatch. I could see the response coming back, but the Lambda from the front end.
Are you using CDK?
I use the CDK.
So the default is 3 seconds or 1 second for a timeout.
Wow.
So you need to change the default on CDK. I learned that by my own pain. So yeah, the default here, I'll show it.
Is that even in the white paper?
What?
Is that in the white paper?
You know, I don't know. I was developing this serverless DM Dungeon Master for like Dungeons and Dragons AI agent. And I was doing the whole thing for just like a little mini hackathon. And I think I spent way much longer than I should have spent to figure out that the default was so low. I was like, why?
Sets the Lambda to 1 second or?
I have to pull up the call that's causing it, so. It's because of
Total.
the CDK though. The CDK is setting a different timeout.
Wow, maximum is 15. Yeah, always like crazy.
I thought it was saying like 29 seconds. It was weird, because I was seeing the response in cloud function then. Timeout.
Well, did you say that 15 minutes is the maximum for the execution time of a lambda?
Of a lambda, you can increase, you can like get special request privileges and requests with support, but the out of the box is 15 minutes.
I didn't know they had a time limit. Interesting.
It's more than 15 minutes, I think it's probably the sign.
Yeah.
Yeah, so I have a proxy lambda that calls out. So this is the session proxy that ends up as a lambda function. And I found out that, that would be really helpful. And also dark mode is very, very easy in classrooms, right? So let me zoom in as well now. So this is, wow, let me figure out how Zoom works on a computer that can go full screen or something. There we go. We'll just do this. We'll zoom in both ways. Does that work? Okay. So this is CDK. So this is like AWS's infrastructure as code. And so this is defining a Lambda node function in the latest version of the CDK. And I had to leave a comment to myself to remember that the default was 3 seconds. So yes, you have to set the duration. So most likely you're getting a timeout because the default is there. Yeah, so if you're making like a session proxy or something and it's failing there, it will still call. So you'll see like calls and things happening, but it will never come back to you because it's like, I mean, there's no way that a call to bedrock takes 3 seconds, sorry. 60 seconds might be, a little ambitious as well.
What is Bedrock? Sorry.
Bedrock is Amazon's like AI.
Oh, okay.
So, but instead of you having to make your entire model or anything, you can use Claude or something under the hood. So this one's using Claude 3.5.
Mhm. And this, is this Node or what programming language is this?
This is TypeScript.
TypeScript, okay.
Yeah, most part, if I write anything, it's in TypeScript as a default. And I hope the people that have to deal with me at my hackathon also are okay with TypeScript. Yeah, if you guys want, you can watch me live. I don't know why I volunteered to do this. All right. Actually, I realize I'll stop recording